So my research group, which I call the Applied CFD and Air Design Research Group, is working on studying whether we can use drones for wildfire suppression. Specifically, we're looking at how we can incorporate geographical data and fire history data to inform the design of these aircraft. So we're really looking at two main metrics, which are cost and effectiveness. So one of the things about drones is that they can be a lot cheaper, partly because they're smaller, but also because they can be produced at scale. The other aspect is the effectiveness, and so within effectiveness they have some advantages in that there's no pilot on board, so there's an inherent increased safety, and then they can also do a lot of things that you can't do if there's a pilot on board. So they can fly basically, they can fly at night and they can fly in much more dangerous conditions. So that's kind of what we're looking at. So the most difficult part has been incorporating these sort of transdisciplinary aspects. So I'm an aerospace engineering professor, I'm not a wildfire scientist. So the way that our codes work is you have to tell the code what the aircraft has to do, and so that has to be informed by this other field. And so trying to incorporate that has been the biggest challenge, and that's really what we're still working on. Is now we're trying to incorporate wildfire simulations with basically aircraft simulations layered on top. So far, the best part has really been working with the students. So I started out, even before I was a professor, I started working on this, and I sponsored a fourth-year capstone project at the Schulich School of Engineering, and so now there's been 3 iterations of that, and each year the students have continued to impress me. The other really enjoyable part has been interacting with the wildfire experts and getting to learn more about it, and then also talking to the pilots who actually fly current water bombers has been really enjoyable, and I've learned a lot.